Solving trigonometric equations. Worksheet 3 solutions. Solve for x in the interval of 0 to 360 degrees or 0 to 2 pi. Equation is sin x plus 2 cos x minus 1 equals to 0. Now our first objective is to write this equation in either cosine or in sine. And to do this, what should we do? So what strategy we can adopt is something like this. We can write this as sin x and we can take all these terms to the right side. So we get what? So we'll take it here. So 1 minus 2 cos x. We can write like this, right? Now we can square both sides, right? So when you square both sides, you get sin square x equals to 1 minus 2 cos x whole square. Now remember one thing at this stage, that when you have squared both sides, you have incorporated error in your solution, right? Why is it? Because let us say if there was a negative number like minus 2, then when you square it, then it actually becomes a positive number. It will become plus 4, right? Even 2 when squared will become plus 4. But minus 2 and plus 2 are not equal. That is the difficulty, right? So we have squared even the negative solutions of sin x here, right? You remember sin x is in the domain of 0 to 360, but in quadrant 3 and 4, it is negative. So there is a possibility of getting those answers because we squared it, right? They became positive. Now, that's the case. So you have to check for your solutions at the end. That is a must in this case, okay? We avoided doing for many questions, but in general, it should be done for all the questions when you are dealing with trigonometric equations, okay? That's a rule. Okay, now let's expand and solve. So it is sin square x equals to, when you expand this, you get 1 minus 2 times AB, which is 4 cos x, plus b square, which is 4 cos square x. Now sin square x could have been written as 1 minus cos square x, right? So I'll write this. 1 minus cos square x is equal to 1 minus 4 cos x plus 4 cos square x. Now we can bring all the terms together and then it becomes a quadratic equation in cos x. We get 0 equals 2. So when we bring 1 this side, so 1 minus 1 is 0, so that goes away. We are left, this cos square x adds up, so we get 5 cos square x. And we have minus 4 cos x. Okay. So now we can take cos x common, right? So once we take cos x common, we get 5 cos x minus 4 equals to 0. So that is the factored form of our quadratic equation, and from this factored form we can find solutions, right? Each factor could be 0, leading us to set of solutions for this quadratic equation in the domain of 0 to 360 degrees or 0 to 2 pi. So we have solutions here, and we can write this as 1 cos x equals to 0, right? When I say cos x is equal to 0, then I'll revert back to my sketch of cos x. Whenever I get cos x or sin x equals to 0, I prefer to draw this. It is faster and it's like so obvious when you look at it, right? So those are the solutions, correct? So the solutions for us in the domain of 0 to 360 or 2 pi is x is equals to 90 degrees or 270 degrees, right? And those of you working in radians will write pi by 2 or 3 pi by 2, right? So that is the solution for cos x equals to 0. Now let's look into the second half, which is 5 cos x minus 4 equals to 0. So we have 5 cos x minus 4 equals to 0, right? So that solves to cos x equals to 4 over 5. Now cos x is 4 over 5. Important thing here is that cos x is positive. When cos x is positive, then we have two solutions, right? One in quadrant 1 and the other one in quadrant 4, right? You remember all silver teacup? all silver teacup, or cast rule, C-A-S-T, right? Cast rule. So either way, you get cos as positive in quadrant 4 and in quadrant 1. So we can use our calculator to figure out what is inverse, cos inverse of 4 over 5. So cos inverse of 4 divided by 5 gives us 36.86. Let's write down 36.9. So we have x equals to cos inverse of 4 over 5, and we get 36.86. So I'm writing 36.9 rounded to one decimal place. Correct? Well, 37 was even better for me. Anyway, so that is one answer for us, and the other one is 360 minus 36.9, right? So we can also at times write plus and minus 36.9. That's not a bad way of writing, because for cos function, if you see these are the two values and they are exactly same, so we can write the other value as this is 1, the other one is minus 36.9 degrees, right? So that is not a bad way of writing at all, right? Those of you who are working in radians, I'll suggest them to change the setting of calculator to radians and get the answer, right? So that's how it is. So my solution here is, I'll write solution as, this time I will use plus and minus, right? So we have x equals to plus and minus 36.9, writing in one decimal place, or it is 90 degrees or 270 degrees, right? But is it the real solution? That is what you have to check. So to check this, what you have to do is you have to plug in the values here and then check. So you remember that we incorporated an error, right, by squaring both sides. So now let's check this answer. After all, which ones are the right answers for us, right? So let's do that. So first we'll do 36.86 itself, and we do sine of 36.86 is equals to 3 over 5. So we are now checking the answers. We are doing plus 36.9. So 3 over 5 for sine x. So let me write here, when we check for first answer of 36.9, we get 3 over 5 for sine x, or we can just plug it in for all the values and see do we really get the right answer, right? So, but remember, for checking the answer, we should use at least 4 decimal places in this, right? So let me use 4 decimal places. Or for cos, I could actually write 4 over 5, right? Because cos of x is 4 over 5. So 2 times 4 over 5 will give me what? Will give me exact value of 8 over 5, right? So we get 8 over 5, right? Minus 1. So that is what we get. If you see, it is 11 over 5. 11 over 5 is actually not 1, right? So this is not correct. It is not correct. So we don't really get plus 36.9 is not, so that is incorrect, right? So that is not equal to 0. Do you see it? Do you understand now why checking was important? So when we added plus 36.9, we got 11 over 5 minus 1, which is incorrect, right? In this quadrant, all are positive, correct? If you add positive and positive numbers and 2 times one number, you're not getting the right answer, right? So let's try minus 36.9. So minus 36.9 practically means the sign is in this. So this will be minus, now this, let me write here. So it will be minus 3 over 5 plus 8 over 5 minus 1. So that gives us 5 over 5 minus 1. That is equal to 0, right? So therefore, the correct solution for us is, so this, we should not write solution. These are expected solutions, right? Expected solutions. And we have already found that plus 36.9 is not good for us. So we do have a right solution here, and that one is for minus 36.5. So we have finally one answer, which is this one, and that angle is 36.9. Correct? We got that one. Now let's try 90 degrees. Now, you remember the sine graph? Correct. Sine graph is actually 1 at 90 and minus 1 for 270, right? So that is how the sine graph is. It will go to 1 and then it will go to maximum and then it will be minimum at minus and then go up, right? So sine graph is 1 at 90 degrees. So if I write 1 and cos is 0, 1 minus 1 is 0. That's correct. So 90 degrees is the right solution for us. How about 270 degrees? For 270 degrees, sine is minus 1. So minus 1 and cos is 0. Minus 1 gives you minus 2. So that is also incorrect solution, right? Therefore, the next solution which we really get is when we have 90 degrees, right? So net solution, so our final answer is, in this case, minus 36.9 degrees and 90 degrees. So these are only two possible answers for our problem. The other two are extraneous roots. We do get them, but they don't yield the right result. Reason for that, as you understand, is this particular step here. So when we squared it, right, we made that minus 1 as plus 1, correct? And so we got the wrong answer. So that is how it is, right? So you have to always check your roots and then write down the final answer. Perfect. Thank you. I hope you learned a lot from here and it will be good for you for your test. Thank you.